Hello, this is another video about angles, and in particular we're going to be looking today at angles in a triangle. This is the first of those videos. Okay, so plan is that we are going to be able to find missing angles in a triangle. So we're going to need to know a rule about angles in triangles, and that rule is that angles in a triangle add up to 180 degrees. And that's going to be true whatever type of triangle we've got, whatever size of triangle it is, always all 1, 2, 3 of the angles will add up to 180 degrees. So that means that we can work out missing angles if we know this fact. If we look at this triangle here, I've got 100 degrees at the top, I've got 45 degrees down here, and I don't know what this one is yet, but I can work it out because I know they all have to add up to 180. So what we're going to do is add together the two that we've got so far. We've got 100 and we've got 45, so that makes 145. But we know that 1, 2, 3 have to add up to 180, so let's do 180, take away that 145 that we've got so far, and that will tell us what our missing angle is. So we're going to have to do 0 take away 5, can't do that, so we borrow. 10 take 5 is 5, 7 take 4 is 3, 1 take 1 is nothing. So this angle over here must be 35, and make sure we include the units, degrees. Good. Okay, let's look at a few more examples. We're asked here to find the size of angle XWY. XWY, that's this one here, yeah? So we'll mark that one out as the one we're looking for. What do we know? Well, we know this one's 71, we know this one's 48, so let's see what we've got so far. 71 plus 48, 1 plus 8 is 9, 7 plus 4 is 11, so we've got 119 degrees so far. I need to have, remember, 180, so we're going to do 180, take away 119, and whatever that is should be our answer. So a wee bit of borrowing to do again. 10 take 9 is 1, 7 take 1 is 6, 1 take 1 is nothing, so we've got 61 degrees. Okay, I hope you agree that those two weren't too tricky. We're going to get on to some slightly more complicated ones then. So this one, at first glance, it looks like we've only been told one angle, but we've actually been told two, right? Because this box tells us that we've got a right angle, and a right angle, remember, is exactly 90 degrees. So when we're asked to find the size of angle PRQ, that is the angle that we're looking for, and we do know two angles. We know 52 and we know 90. So let's add those two together. 52 plus 90. I've got 2 and I've got 14. Good, 142 degrees so far, which means to work out the one that we want, we're going to have to do 180, take away 142. And we pop that in the chimney sum, and we're going to get 0 take away 2, can't do that, so we're going to do some borrowing. 10 take 2 is 8, 7 take 4 is 3, 1 take 1 is nothing. I've got 38 degrees is the size of that angle. So if let's write it out properly, PRQ, angle PRQ is equal to 38 degrees. There we go, that's my answer. Another example then. So we've got a new bit of notation introduced in this question, and that's these wee dashes here. So what I've got here is called an isosceles triangle. I'm going to write that out because it's a tricky word to spell. Isosceles. Isosceles, there we go. And an isosceles triangle has two sides that are the same, and we can see which ones are the same because those are the ones with the wee dashes. So this one and this one are the same. But as well as having two sides that are the same, it also has two angles that are the same, and those are the ones at the bottom of those two equal sides. So in this case, this one and this one are the angles that are the same. So in an isosceles triangle, two sides and two angles are the same, and in this particular isosceles triangle, it's this side and this side that are the same, and therefore this angle and this angle that are the same. So let's mark in what we know. We know this is 42 degrees, and because it's isosceles, this has to be 42 degrees as well. So we'll mark that in, 42 degrees. All three, 1, 2, 3, should add up to 180. So let's look at what we've got so far. Well, we've got 42 plus 42. No carrying to be done here. That's 84 degrees. We just need to take that 84 degrees away from our 180. So 180 take away 84, 0 take 4 we can't do, so we're going to borrow. 10 take 4 is 6, 7 take 8, can't do that either, so we're borrowing from this one. 17 take 8 is 9, and nothing take nothing is nothing. So I've got 96 degrees up here. 96 degrees, that was the size of angle STU. So our final answer looks like this. Angle STU equals 96 degrees. Good. Just a couple more then. Okay, we've got another not a right angle triangle, sorry, we've got another isosceles triangle here. This time these two are the sides that are the same, which means these two are the angles that are the same. This one and this one are going to be the same. Now we know that this orange guy and this orange guy plus 36 needs to make 180, but we've only got one angle here. So what can we do? Well, what we're going to have to do is take away this 36. So take away 36, because that's the only bit we know so far, which is going to give us 144. Now, that means that these two angles added together have to make 144, right? Because we've got 144 plus 36 makes 180. That's our triangle. So these two together are going to be 144. So what are they each individually? Well, because they're the same, we can just do 144 divided by 2. And again, maybe you can do that in your head. Maybe we choose to do a bus stop. I'm going to pop it in a bus stop just quickly. We're going to have how many 2's in 1? None of them, so we carry it across. How many 2's in 14? 7. How many 2's in 4? 2. So each of these has got to be 72 degrees because they've got to be the same, and all three have to add up to 180. And we can double check that. If I add these together, I've got 144 plus the 36. Yeah, that's back to 180. Good. So we've got the right answer. So what's the answer to this question? The question is the angle STU. Oh no, I've carried over the same name from last time, isn't it? What I meant to ask here is not angle STU, in fact, but angle VXW. Apologies. Let's go back there. So angle VXW is equal to VXW 72 degrees. Apologies for that mistake there, guys. And final example we'll look at, find the side of angle ABE. Now this is a slightly more complicated looking diagram, but we're still going to use the same ideas that we have done so far. So first of all, where is angle ABE? Well, ABE is this one here, isn't it? On the outside down here. This is the angle we're looking for. Okay, so it might not be immediately obvious what we're going to have to do here, so let's just work out things that we can find, and then we'll see if we can get closer to finding this one. So what kind of triangle is this? This is an isosceles triangle, isn't it? This side and this side are the same, which should mean we've got two angles that are also the same. Those are these two angles. So if this is 64 degrees, this one up here is also going to be 64 degrees. And so since this is a triangle, we can also work out what this angle is. We could work out that bit. Because we've got 64 plus another 64, that's 128. So to find out what this one is, those three, 1, 2, 3, have to add up to 180. So let's do 180, take away 128, see what we get there. Oops, that's a 7. 10 take 8 is 2, 7 take 2 is 5, 1 take 1 is nothing. We've got 52. So this angle is 52 degrees. Now, has that helped us? Has that helped us work out what ABE is? Oh, I think it has, because these, and in fact these, are vertically opposite, aren't they? Do you remember we said that when we've got a couple of straight lines crossing each other, then at the crossover points, the ones that are opposite are equal. So these two would be equal, and these two would be equal, so that means that this angle here on the outside has also got to be 52 degrees. So our answer is that angle ABE is equal to 52 degrees. There we go. Cool. I'll see you later, guys. Bye-bye.